Okay, so today, kiddos, we are going to be dealing with solving equations with variables on both sides. So what we've been doing in our lessons is talking about equations that kind of look like this, where you have variables on only one side of the equal sign. So like right here, you have 3x. On the other side is just a number. Here, same thing. But we're going to move on to solving equations that look like this today, where on one side we might have 3x, but on the other side we have also the variable x. So we have variables on both sides of the equation. So what we're going to be focusing on today is talking about the procedure for how we deal with a problem like this. Where do we start? Okay, how do we know where to move things around so that we can solve? But basically what we're going to do is we're going to take this and convert it into a two-step equation. So it's just one little extra layer of difficulty, but we can turn it into something that we've been working with. So really straightforward. Okay, here are some rules that I explain to my students to make sure that they know where to start and where to go. So remember, your goal is to get variables and numbers on separate sides. So you want your variables to be on one side, your numbers to be on the opposite side. And the way you determine what side the variables go on is by looking for the greatest positive variable. So when you look at your equation, you're going to right away know what side the variables go on because you always look for the greatest positive variable. That way, we're going to avoid having to do things like divide by a negative number. It just makes our lives a lot easier. Okay, so once you move the variables to one side, you're going to move your numbers to the opposite side, and then you work backwards to solve, just like any other solving equations problem. Let's look at our first example. So our first example, you can see here that we have 7x minus 8 equals x plus 16. One thing to remember is that when there's no number in front of the x, it is a 1. You don't have to write the 1, but some students feel more comfortable writing the 1 in so they don't forget that it's actually a value. You just don't have to write it. Okay. Now, immediately I can tell that 7x is a greater positive number than 1x. So my x's are going to go here on the left side. Okay. That means that 7x gets to stay where it is, but this 1x that's on the right has to go bye-bye. We got to make that go away. So to make it go away, we're going to do the opposite. We're going to subtract 1x from both sides. And when I do that, I'm going to create a separation of my steps. 7 take away 1 leaves us with 6x. The minus 8 comes down. The 1x and the negative 1x cancel out, and 16 is left over. And now we have exactly what we started with in class last time. We have two-step equations. So remember, I need x by itself. So to do that, I'm going to get rid of everything around x. I'm going to start by getting rid of this negative 8 by adding 8 to both sides. The negative 8 and the 8 cancel out. 6x is equal to 16 plus 8 gives us 24. And now, in order to get rid of the 6, I have to do the opposite of multiplying, which is dividing. So I'm going to divide by 6 on both sides. The 6 cancels here, and x equals 24 divided by 6 is positive 4. And so that's going to be our final answer for that problem. Okay? So again, going through the steps, the first thing we're going to do is move our x's to the side with the greatest positive value of x. Then we're going to move our numbers to the other side, and then we work backwards in order to solve for x. Okay, here's another example where we're going to follow the same steps. So looking at my two options, on one side I have 3x minus 8. On the other side I have negative 2x plus 7. So what I'm going to do is immediately 3x is the greater positive value. So I'm going to be moving my x's to the left side again. In order to move negative 2x, I do the opposite. So I'm going to add 2x to both sides. Three x plus 2x leaves us with 5x. The negative 8 comes down. These cancel out, and I bring down the positive 7. And now I have a two-step equation, really simple. I need to get rid of everything else around x so that x is isolated. I'm going to add 8 to both sides. Okay, the negative 8 and the 8 cancel out. 5x equals 7 plus 8 is 15. And now I divide by 5. The 5's here cancel, and x is left over. That's exactly what I wanted. I'm trying to isolate x. 15 divided by 5 leaves us with 3. Okay. Now, these steps are very repetitive. We're following a procedure here. It's this whole process of going through these steps. So on the next example, just follow along with me. We're going through the same steps, and we're building that muscle memory, right? We're doing multiple problems with the same process so that we can eventually be able to do this like it's second nature. Okay, on this problem, remember, we're identifying where our x's are going to go. So I have one side 6x plus 12. On the other side, 11x minus 33. I can already tell that 11x is the greater positive value. So I am going to move my x's towards the right. So 11x gets to stay. The 6x right here has to go bye-bye. So I'm going to do that by subtracting 6x from both sides. These cancel out, and 12 is the only thing left over on that side. 11 take away 6 is going to give us 5x. And then I bring down the negative 33. And once again, we have a two-step equation. I have to get rid of everything around the variable, so I'm going to add 33 to both sides. 12 plus 33 is going to give us 45. The 5x can come down, and then the negative 33 and positive 33 cancel out. I have one more step. I need to get rid of the 5, so x is isolated. This is being multiplied, so the opposite of that is dividing. 45 divided by 5 gives us positive 9. The 5's cancel out, and x is isolated. That's what I wanted. Okay. In all of these problems, I've been saying, look for the greatest positive value. But what if we have an example where both of the variables are negative? So our last example today, we have example number 4. We have negative 5x plus 20 is equal to negative 2x plus 11. Both of those are negative values. So what I need to do is move my variables towards the one that's closest to being positive. Okay, the one that's closest to being positive. Because negative 2 is closer to 0, this is the value that is closer to being positive. So we are going to let negative 2x stay, but the negative 5x is going to have to move. So to move that, I do the opposite. I'm going to add 5x to both sides. The negative 5x and the 5x are going to cancel out. 20 is going to come down. Negative 2 plus 5 is going to give us positive 3. Remember this tug of war. 5 is bigger, so it's going to be a positive 3x plus 11. And now I have a really easy two-step equation. I'm going to subtract 11 from both sides. 20 take away 11 is going to leave us with positive 9. 3x comes down. The 11 and negative 11 cancel out. I'm going to divide both sides by 3. And my final answer is x is equal, 9 divided by 3 is positive 3. There we go. Okay, so if you follow those procedures, first identifying which side you move your variables to, then you are going to move your numbers to the opposite side, work backwards to solve for the variable. You're going to be able to do any problem like this no matter how difficult it looks.